Hola, I'm Fernando Martinez from IBM. Welcome to this demo video for our paper Better Together, an evaluation of AI-supported code translation. Our paper describes a study of software engineers working with the state-of-the-art neural machine translation model to understand if it was actually helpful for completing a coding task. One of the challenges of working with these models is that they produce imperfect code that contains bugs and errors that people need to find and fix up. In this demo, we showcase follow-on work from our paper, in which we are developing intelligent user interfaces that address the challenges faced by participants in our study, and we encourage you to read our paper to learn more about these challenges. First, code correspondence is designed to help people understand why a generative code model produced the output it produced. Second, regions of model uncertainty is designed to help people easily understand different output alternatives produced by the model without overwhelming them. And third, post-edit suggestions is designed to assist people as they make edits to the AI-produced code. This demo represents work in progress since we completed the study we report on in the paper, and we are currently implementing these features as an extension for the popular VS Code editor. Let's take a look at each feature in detail. Code correspondence is a feature designed to help users understand why the model produced a specific source code token. This feature arose from our observation that many participants in our study spent a lot of time trying to understand how certain snippets of Python were produced from the source Java code. They would look at the Java and Python code side by side and make guesses as to which tokens in the Java code matched up with which tokens in the Python code. With code correspondence, users are able to cursor into a token in the source code and see its corresponding token in the code translation and vice versa. We compute token correspondences by extracting the token's encoding from the model and computing distances between it and the encodings of all of the tokens in the counterpart source code to find the closest match. This feature provides a straightforward way to interpret the model's output. We believe its simplicity, compared to the other schemes that highlight tokens based on attention weights, will help software engineers better understand why the model produced the output it produced. Some people in our study received multiple translation alternatives, because it's often the case that neural machine translation models can produce higher quality results when they are allowed to generate multiple options. However, this was a really poor user experience, and participants were frustrated trying to figure out how the multiple alternatives differed from each other. We came up with another way to capture the benefits of having multiple translations without overwhelming users, which we call regions of model uncertainty. We compute these regions using an n-way diff across all of the generated translations. Then, we underline code segments where there was a disagreement across the translations. A pop-up menu shows a list of the different alternate translations the model produced for that region. Each alternative has a confidence score, showing how many translations contain that specific alternative. Users can select an alternative via the Quick Fix button, which replaces the region with the code they selected. Our final feature is about making the translation process more interactive by enabling the model to react to a person's edits to the code. With the post-edit suggestions feature, whenever the user makes a change to the AI-generated translation, we invoke the model to reevaluate the translation in light of that edit. This process results in new suggestions from the model about other changes that may be required to make the code function. This feature provides a way for people to work in a more iterative, back-and-forth style rather than the push-button-get-results mode we examined in our study. To wrap up, the emphasis of our work is to understand how generative AI technologies can act as performance enhancers or super tools. This demo shows 3 new design ideas for an intelligent user interface for working with code, and in future work, we plan to evaluate their effectiveness. Thank you very much for watching our demo.